Hello everyone, this is Dr. K. Akilan, Department of Mathematics, St. Joseph College of Engineering, OMR, Chennai. Today I am going to present a topic as Gram-Schmidt orthogonalization. This topic is under engineering mathematics. So now we are moving to the working rule and formulas for the Gram-Schmidt orthogonalization. So working rule is nothing but given the basis V1, V2, V3. So to find the orthogonal basis, we need to find U1, U2 and U3. So here U1, U2, U3 is the formulas are given. Let us consider U1 equal to V1 and U2 equal to V2 minus inner product of V2 comma U1 divided by norm of U1 square into U1. Then third one is U3 equal to V3 minus inner product of V3 comma U1 divided by norm of U1 square into U1 minus inner product of V3 comma U2 divided by norm of U2 square into U2. So now we know the formulas for U1, U2, U3. Just apply these formulas, then we can find the orthogonal basis. Fine. So orthogonal basis, inner orthogonal basis W1, W3, W3. W1 is nothing but U1 divided by norm of U1, whereas W2 and W3 are similarly U2 divided by norm of U2, U3 divided by norm of U3. Fine. So apply these formulas into our problem, then we can find the orthogonal basis of U1, U2, U3 and W1, W2 and W3. So next, this is the problem. In R power 3 of R with B equal to 1, 0, 1, 1, 0, minus 1, 0, 3, 4. Using Gram-Schmidt process, find the orthogonal and orthogonal basis. To find the orthogonal U1, U2, U3 and find the orthogonal basis W1, W2 and W3. Okay. So the answer for this problem, given basis W. So these are the basis of this problem. V1, V2, V3. So V1 is nothing but 1, 0, 1. V2 is nothing but 1, 0, minus 1. V3 is nothing but 0, 3, 4. So V1, V2, V3. Fine. So to find the orthogonal set, W1, W2 and W3. W1, W2 and W3. So here, so to find the orthogonal basis, we need to find U1, U2 and U3. Similarly, find the orthogonal basis W1, W2 and W3. Okay. So the given basis, this is V1. This is V1. This is V2. And this is V3. Okay. So apply the U1 formula, U2 formula, and U3 formula to find the orthogonal set. So U1 is nothing but V1. So here V1 is 1, 0, 1. So U1 simply says that V1, 1, 0, 1. Fine. So U2 is nothing but V2. We have a formula for U2. V2 minus W2, U1. That means inner product of U2, U1 divided by norm of U1 square into U1. So we know the formula, we know the value of U1, right? U1 is nothing but V1. So substitute the U1 value here and substitute the V2. V2 is nothing but this value. So substitute the V2 value and U1 value, inner product of these two terms and the norm of U1. Then we can find the U2 value, right? So first we need to find inner product of V2, U1. V2 is nothing but 1, 0, minus 1. So substitute the V2 value. Similarly, substitute the U1 value. U1 is nothing but V1, right? U1 is nothing but V1. So substitute these two value And here the simple mathematics only. There's a corresponding first term and corresponding second term and corresponding third term only associated. So 1 into 1 is nothing but 1 and 0 into 0 is nothing but 0. Here both positive, so plus 0, and here positive and negative, so minus. 1 into 1 is nothing but 1. So finally we found the answer is 0. So inner product of V2 comma U1 is nothing but 0, right? So next, so substitute inner product of V2 comma U1 value. We already find this is nothing but 0, and U1 is nothing but V1, 1 comma 0 comma 1. And also we need to find norm of U1 square. So norm of U1 is nothing but, again we have a formula, the inner product of U1 comma U1, right? So 1 comma 0 comma 1. U1 is something but U1, right? 1 comma 0 comma 1, 1 comma 0 comma 1. So again, same process, the inner product of two terms associated with the corresponding values only. So 1 into 1, 1 plus 0 into 0, 0, comma 1 into 1 is nothing but 1. So answer is 2. So substitute inner product of V2 comma U1 and also substitute the norm of U1 square here. And also substitute V1 value. Similarly, V2. V2 is nothing but distance. Substitute all the values in U2. We can get the values. So here the inner product of V2 comma U1 is nothing but 0. So the full term is going vanished, which means 0. So simply we can say that U2 equal to V2, right? V2 is nothing but 1 comma 0 comma minus 1, right? So V1 is nothing but U1, V2 is nothing but U2, fine. So next again, we have a formula for U3. So U3 is nothing but V3 minus inner product of V3 comma U1 divided by norm of U1 square into U1 minus inner product of V3 comma U2 divided by norm of U2 square into U2. Fine. So again, first step is going to find the value of inner product of V3 comma U1 and V3 comma U2. So first V3 comma U1. What is V3? V3 is nothing but 0 comma 3 comma 4, right? And then what is U1? U1 is nothing but 1 comma 0 comma 1. So substitute this value. Again, the process of inner product. So 0 into 1, 0. 3 into 0, 0. 4 into 1 is 4. So inner product of V3 comma U1 comma is V3 comma U1 is nothing but 4. Fine. Similarly, we can find V3 comma U2, the substitute the V3 value and U2 value. V3 is nothing but this term, right? 0 comma 3 comma 4. And also U1 is nothing but 1 comma 0 comma 1. Okay. So again, substitute the values. So here U2 value is nothing but 1 comma 0 comma minus 1. So 0 into 1, 0, 3 into 0, 0, 4 into minus 1, 4. So inner product of V3 comma U2 is nothing but minus 4. And similarly, we can find norm of U1 square and norm of U2 square. Norm of U1 already found, right? From the previous step, norm of U1 is nothing but 2. So substitute norm of U1 square is nothing but 2. Similarly, we need to find norm of U2 square, right? So norm of U2 value is nothing but, here U2 value is nothing but V2, right? So 1 comma 0 comma minus 1. Substitute 1 comma 0 comma minus 1 here and 1 comma 0 comma minus 1. So after operating this inner product, we can get the values U2 square also 2. So substitute the values of V1, inner product of V3 comma U1, inner product of V3 comma U2, norm of U1 square, norm of U2 square, and V3 value here we can find 0 comma 3 comma 3. How? So substitute V3 value here. V3 is nothing but 0 comma 3 comma 4. Okay, fine. Then next inner product of V3 comma U1. Inner product of V3 comma U1 is nothing but 4 divided by U1 square is nothing but 2, right? And also U1 value. U1 is nothing but V1, right? U1 is nothing but V1, 1 comma 0 comma 1. Okay. Similarly, we can substitute V3 comma U2, inner product of V3 comma U2. Inner product of V3 comma U2 is nothing but minus 4. Again, U2, norm of U2 is nothing but 2. And then U2 is nothing but u2 is nothing but v2, right? v2. So our value is 1, comma 0, comma minus 1. Substitute this value and operate this. So here the value is 0, comma 3, comma 4 as it is minus. So after divide this 2 into 1, comma 0, comma 1 minus into minus plus 2 into after dividing this, so 2 into 1, comma 0, comma minus 1. So this is simple operation, multiplication only. 2 into 1, 2, 2 into 0, 0, 2 into 1, 2, plus 2 into 1, 2, 2 into 0, 0, 2 into minus 1, minus 2. So again the same process. So we can add first these two and then this. So what will be the answer? So 0 minus 2, 2, 3, 4. The answer is similarly minus 2, comma 0, comma minus 2. 2, comma 0, comma minus 2. The final answer is u3 equal to 0, comma 3, comma 0. Actually, okay, fine. So in this PDF, some mistakes. Okay. So after the solving this, we can get u3. So similarly, we need to find u1, u2, u3. Orthogonality is nothing but 1, comma 0, comma 1. u1 is nothing but 1, comma 0, comma 1, and u2 is nothing but where is u2? 1, comma 0, comma minus 1. u1 is nothing but 1, comma 0, comma 1. u2 is nothing but 1, comma 0, comma minus 1. And u3 is nothing but 1, 0, comma 3, comma 0. Right. So next we need to find orthogonal basis. Orthogonal basis is nothing but W1, W2, and W3, right? So W1 is equal to U1 divided by norm of U1, which is equal to, we know the value of U1, right? 1, comma 0, comma 1, and divided by U1 square is U1 square. Yes, norm of U1 square is the value 2, which means norm of U1 equal to square root of 2. So this value is corresponding to both the terms. So 1 divided by root 2, 0 divided by root 2 is nothing but 0, 1 divided by root 2. Similarly, W2 is nothing but U2 divided by norm of U2, which is equal to 1, comma 0, comma 1 is nothing but U2 divided by square root of 2. Norm of U2 whole square equal to 2, which means norm of u2 equal to square root of 2. Similarly, each term should be divided by square root of 2. 1 divided by square root of 2, 0 minus 1 by square root of 2. W3 is nothing but u3 divided by norm of u3 equal to 0, comma 3, comma 0 divided by 3 equal to 0, comma 1, comma 0. Fine. So similarly, we can find the same problems. So next problem is let R3 have the Euclidean inner product. Use Gram-Schmidt process to convert basis B equal to U1, U2, U3, where U1 equal to 1, comma 0, comma 1, U2 equal to minus 1, comma 1, comma 0, and U3 equal to minus 3, comma 2, comma 0 into orthogonal basis. Okay. So what are the given bases? So we need to find U1, U2, U3, and also W1, W2, W3, right? So we know the value of bases V1, V2, V3. The given bases are we can consider as V1, V2, V3 simply. So orthogonal set is U1 is nothing but V1, which means the first term is nothing but U1. U1 equal to V1. So we know the value of U1 is 1, comma 0, comma 1 as it is the V1. So next we need to find U2. We have a formula for U2, right? U2 equal to V2 minus inner product of V2, comma U1 divided by norm of U1 whole square into U1, right? So we know the value of U1 and we know the value of V2. And we need to find the value of inner product of V2, comma U1. Just simply apply the V2 value and U1 value and then save simple operations on the corresponding values only, multiply and then adding subtraction, then we can find the inner product of V2, comma U1, right? So apply the value of V2. V2 is nothing but minus 1, 1, 0. And then U1. U1 is nothing but V1, right? 1, comma 0, comma 1. So substitute here inner product of minus 1 comma 1 comma 0 and comma 1 comma 0 comma 1. Okay, well, so minus 1 into 1 is nothing but minus 1. 1 to 0 is nothing but 0. 0 into 1 is nothing but 0. So after the operation, we can get the inner product of V2 comma U1 is nothing but minus 1. Good. Fine. Next, we need to find norm of U1 square, right? We have a formula for norm of V1 whole square, which is nothing but inner product of U1 comma U1. The same term only operate. U1 comma U1. So apply the U1 value. U1 value is nothing but 1 comma 0 comma 1, right? Comma. Then U1 value 1 comma 0 comma 1. So operate here. What will be the answer? 1 into 1 is nothing but 1. 0 into 0 is nothing but 0. 1 into 1 is nothing but 1. So finally we can get the answer is 2. Norm of U1. So we find we have the value of inner product of V2 comma U1, norm of U1 square, right? Just simply we can apply from the question. V2 is nothing but minus 1 comma 1 comma 0 and U1 is nothing but V1, 1 comma 0 comma 1. Substitute these all values along with this formula. We can find the U2, right? So U2 is nothing but what is V2 value? Minus 1, 1, 0. Minus what is inner product of V2 comma U1? Minus 1 divided by norm of U1 square. What is norm of U1 square? To substitute these values and also we need to substitute U1 value. U1 is nothing but simply V1. 1 comma 0 comma 1. So simple mathematics only. Minus 1, 1, 0, minus into minus plus 1 divided by 2 into 1 comma 0 comma 1. So this fraction is nothing but each term. So 1 by 2, 0 divided by 0 into 1 by 2 is nothing but 0. 1 into 1 by 2 is nothing but 1 by 2. So again, this is a simple mathematics. So minus 1 plus 1 by 2 is nothing but minus 1 by 2. 1 plus 0 is nothing but 1. 0 plus 1 by 2 is nothing but 1 by 2. So we found the formula for U2. So U2 value we found. Okay, next U3. Again, we have a formula for U3, right? So in this type of problem, we should memorize the U1 value, U2 value, U3 value, which means U1, U2, U3 formulas, and also W1, W3, W3 formulas. Okay, so U3 formula. What is the U3 formula? Oh, sorry. What is U2 formula? Sorry, U3 formula. U3 is nothing but V3 minus inner product of V3 comma U1 divided by norm of U1 square into U1 minus inner product of V3 comma U2 divided by inner product norm of U2 whole square into U2. Okay, so again we need to find inner product of V3 comma U1, inner product of V3 comma U2, and also we need to find norm of U1 square, norm of U2 square, and substitute the all values of U3, which means V3 inner product of V3 comma U1, inner product of V3 comma U2, norm of U1 square, norm of U2 square, U1, U2. Substitute all these values and we can get the value of U3. Okay. What is inner product of V3 comma U1? V3 comma U1 is nothing but inner product of substitute a V3 value and U1 value. What is V3? V3 is nothing but minus 3, 2, 0. Substitute minus 3, 2, 0. What is U1? U1 is nothing but V1, right? We have a formula, right? U1 equal to V1, V2 equal to some formula, V3 equal to, again we have a formula. So similarly, U1 is nothing but V1. So substitute V1 value here. So what will be the answer? Minus 3 into 1 is nothing but minus 3, 2 into 0 equal to 0, 0 into 1 is nothing but 0. So finally, inner product of V3 comma U1 is nothing but minus 3. Similarly, we can find inner product of V3 comma U2, right? Equal to inner product of V3 value. V3 value is nothing but minus 3, 2 and 0 comma U2 value. What is U2 value? Minus 1, by 2, comma 1, comma 1 by 2, right? So again, we operate the simple mathematics. Minus 3 into minus 1 by 2, which is nothing but 3 by 2, plus here the both terms positive only. So 2 into 1 is nothing but 2, and 0 into 1 by 2 is nothing but obviously 0. So what will be the answer? Inner product of, so substitute, it's adding these two terms only, 3 by 2 plus 2. What will be the answer? 7 by 2, right? So numerator and denominator should be multiplied by 2. So 2 into 2 equal to 4 divided by 2. 4 plus 7, 4 plus 3 divided by 2 is nothing but 7 by 2. So again, we found the value of inner product of V3, U2. Fine. The next, we need to find U1, norm of U1 square and norm of U2 square, right? So norm of U1 we already found, right? Norm of U1 is nothing, norm of U1 square is nothing but 2. Similarly, we need to find norm of U2 square. So what is U2 value? Minus 1 by 2, comma 1, comma 1 by 2. So substitute this value for U2. So both terms are same. So multiply these two, 1 by 2 into 1 by 2, which means minus 1 by 2 into minus 1 by 2 is nothing but 1 by 4. 1 into 1 is nothing but 1. 1 by 2 into 1 by 2 is nothing but 1 by 4. So 2 by 4 is not 2 by 4 plus 1, right? So what will be the answer? 2 by 4 is nothing but 1 by 2. 1 by 2 plus 1 is nothing but 3 by 2. So norm of U2 square equal to 3 by 2, right? Okay. So substitute these all values in U3, we can get the U3 value. So here, so what is V3 value? So substitute in formula, V3 is nothing but minus 3 to 0, right? Minus 3 to 0. Then inner product of V3, U1. What is inner product of V3, U1? Minus 3, right? And divided by 2. From this, so norm of U1 square is nothing but, what is norm of U1 square? 2. So substitute in this place, replaced by 2. And also we know the value of U1. U1 is nothing but V1. V1 value is 1, 0, 1. Substitute this value minus inner product of V3, U2. What is V3, U2? Answer is 7 by 2 divided by norm of U2 square. What is norm of U2 square? 3 by 2. 7 by 2 divided by 3 by 2 into U2 value. What is U2 value? U2 is nothing but minus 1 by 2, 1, 1 by 2, right? So substitute this value along with this formula and simplify these terms. And for this, simply as this term, and here minus 3 to 0, minus to minus plus 3 by 2. Like this term should be associated with this, each term. So 3 by 2, 0, 3 by 2. So 7 by 2 into this term reciprocal. So 2 by 3 cancel 2, 7 by 3 into minus 7 by minus 1 by 2, 1, 1 by 2. Okay, fine. So so minus 3 to 0 plus 3 by 2, 0, 3 by 2 plus 7 by 3, 7 by 3 minus into minus plus, so 1 by 2 plus into minus minus, so minus 1 plus into minus is minus, so minus 1 by 2. So again multiply this term into each term, 7 by 6 minus 7 by 3 plus minus 7 by 6, right? So this term as it is, we kept that. So minus minus 3 minus 3 minus 3 plus 3 by 2. The corresponding values only should be added. So minus 3 plus 3 by 2 plus 7 by 6, comma 2 z plus 0 minus 7 by 3, comma 0 plus 3 by 2 minus 7 by 6, right? So, okay, the simple operations only. So minus, so here multiply by 3 by, so we need to the numerator should be 6, right? Or else yes, the numerator should be 6. So multiply and operating this, we can get the values. 6 multiply, numerator denominator should be multiplied by 2. So minus 6 plus 3 divided by 2 plus 7 by 6. So here multiply by 3 by 3. So 6 minus 7 divided by 3, comma. Here multiply by 3. So the LCM is 12. So here, yes. So 6 by 6. So 6, 18 minus 7, 14 by 12. So similarly, the simple mathematics, and we can find the answer is 1 by 3 minus 1 by 3 minus 1 by 3, 1 by 3. Right? These are the simple steps only. So 1 minus 1 by 3, 1 by 3, 1 by 3. Fine. So this is nothing but U1. So U1, U2, U3, all terms are finally we concluded. And now the orthogonal basis, right? V1 is nothing but U1 by norm of U1. U2, W2 is nothing but U2 by norm of U2. W3 is nothing but U3 by norm of U3, right? So U1 is nothing but U1 is nothing but V1. So 1 comma 0 comma 1. Substitute here. And also we know the value of norm of U1 square. So norm of U1 square is nothing but 2, which means norm of U1 equal to square root of 2, right? So similarly, we know the value of U2 and W2. From this value, we can find W2, right? So we know the value of U2. U2 is nothing but minus 1 by 2, 1, 1 by 2, right? Similarly, we know the value of norm of U2 square. U2 square is nothing but 3 by 2. Similarly, we know the which means we can find the value of U2, the square root of 3 by 2. Similarly, we know the value of U3. U3 is nothing but where is U3? Yes, minus 1 by 3, minus 1 by 3, and 1 by 3. So substitute here, and also in the value of U3, norm of U3 square. Norm of U3 square is inner product of U3 comma U3. Substitute U3 value. U3 value is nothing but minus 1 by 3, minus 1 by 3, 1 by 3, comma minus 1 by 3, minus 1 by 3, 1 by 3. Right? So multiply these terms. Minus into minus plus 1 by 9 plus minus into minus plus 3 into 3, 1 by 9 plus 1 by 9. So 3 by 9, 3 by, right? Denominator is same. So 1 plus 1 plus 1 divided by 9. So 3 by 9 is nothing but 1 by 3. Am I right? So substitute the U1, U3 whole square is 1 by 3, which means U3 equal to square root of 1 by 3. So here, this is 1 by 3. Okay. So this is 1 by 3. So my U3, so substitute these, we already substitute U1, norm of U1, U2, norm of U2, U3, norm of, from this term, we can find the W1, W2, W3, right? So this is nothing but this denominator should be associated with each term, right? So W1 is nothing but 1 by square root of 2, 0 divided by square root of 2 is nothing but 0, 1 divided by square root of 2 equal to, of course, 1 by root 2. So similarly, W2, minus 1 by 2 into this just reciprocal. So minus 1 by 2 into square root of 2 by square root of 3, comma, minus, comma, root 2 by 3, root 2 by 3, which means 1 into root 2 by 3, comma, 1 by 2 into root 2 by 3. So multiply this term, minus 1 by square root of root 2 divided by root 3, comma, square root of root 2 divided by root 3, comma, 1 by square root of 1 by, yes, those, this 2 is nothing but root 2 comma root 2, right? We can write. So 1 root 2 cancelled by 1 root 2. The balance is 1 square root of 2 into square root of 3. Similarly, we can find W3 also. So what is W3? Minus 1 by 3 into square root of root 3 divided by square root of 1. Square root of 1 is nothing but 1. So here the 1 root 3 is cancelled. This root 3 is 3 is nothing but root 3 into root 3. So what is the first term? Minus root 3 divided by root 3. So answer will be minus 1. Answer will be minus 1. So this term is cancelled, right? Answer will be minus cancelled. So what this term is cancelled by this term. So answer is minus 1 by root 3. Yes, minus 1 by root 3. Similarly, we can find the next term. My same thing only. Same. Again, we have second term is minus 1 by root 3. Minus 1 by 3 only there. So again, the value is minus 1 by root 3. The third term is negative sign only. So here the positive. So answer will be positive 1 by root 3. So what is W3? So what is W3 value? This is for your reference only. This page is missed. Okay. So what is W3? What is W3? W3 equal to minus 1 by root 3, comma, minus 1 by root 3, comma, 1 by root 3. Okay. Okay, done. So this is how this Gram-Schmidt problem processed. Okay, fine. So just one small recap. So first we should know the value of U1. That means the formula of U1, U2, U3. So what is Gram-Schmidt orthogonalization? In this problem, we need to find the orthogonal values like U1, U2, U3, and also we need to find the orthogonal basis W1, W2, W3, right? This U1, U2, U3, and W1, W2, W3, right? We have a formula for U1, U2, U3, and also W1, W2, W3, right? So what is the U1 value? U1 is nothing but V1. U1 equal to V1. And also U2 is nothing but we have a formula for U2, V2 minus inner product of V2 comma U1 divided by norm of U1 whole square and U1. Similarly, we have a formula for U3. U3 equal to V3 minus inner product of V3 comma U1 divided by norm of U1 square into U1 minus inner product of V3 comma U2 divided by norm of U2 whole square into U2, right? Norm of U2 square into U2. So substitute the all values U1, V1, V2, V3, all these terms, and then we can get the U1, U2, U3 values. Fine. Similarly, we can find the W1, W2, W3 with the help of the formulas. Whereas W1 is nothing but U1 by norm of U1 and W2 equal to U2 divided by norm of U2 and W3 is equal to U3 divided by norm of U3. Okay. And also we know the value, how to find, we know how to find the inner product of these two terms like V2 comma U1, right? How to find? Substitute V2 value, V2 value and U1 value. Then, okay, fine. What is V1, V2, V3? V1, V2, V3s are nothing but the given vectors. So whatever the vectors given, then we can take it as the V1, V2 and V3. Okay. So U1, U2, U3 from V1, V2, V3, we can find with the help of the formula, we can get the U1, U2, U3 value. Fine. So substitute these values and then the operation of inner product of this two term is nothing but the simple terms. Substitute these two vectors and multiply the corresponding value. We can multiply the corresponding value and then we can get the again vector, and that vector is nothing but our inner product of V2, V1. And also how to find norm of U1 square. Norm of U1 square is nothing but norm of U1 square equal to inner product of U1, U2. Again, the U1 value, substitute the two terms, and then the operator with U1, U1. The corresponding value should be multiplied and then operate the addition, multiplication, and addition, multiplication, subtraction. Then we can get the norm of U1 square. Norm of U1 square. Similarly, we can find norm of U1 square, norm of U1, which means the value is supposed to, we can say that norm of U1 is equal to square root of 2. See, these are the simple steps, and here we solved two problems, right? Yes. Okay. So okay, we can find U1, U2, U3, and similarly W1, W2, W3. Yes. Thank you.